A systematic global analysis of GPS time series data from nearly 100 large earthquakes suggests the existence of a precursory phase of fault slip that occurs about 2 hours before seismic rupture. The analysis of Global Positioning System (GPS) time series data from nearly 100 large earthquakes worldwide has unveiled evidence for a precursory phase of fault slip, which occurs approximately 2 hours before seismic rupture. If it can be confirmed that earthquake nucleation often involves an hours-long precursory phase, and the means can be developed to reliably measure it, a precursor warning could be issued. The quest to predict large earthquakes is a long-standing, yet elusive goal. Short-term earthquake prediction, which involves issuing a warning anywhere from minutes to months before a quake, depends on the presence of a clear and observable geophysical precursor signal. Prior retrospective studies have proposed that a slow aseismic slip can be seen in faults ahead of the main shock, serving as a possible precursor. However, the connection between these observations and seismic ruptures remains unclear. This uncertainty arises as these observations do not directly precede an event and often occur without an ensuing earthquake, leaving the existence of a precise precursory signal for predicting large earthquakes in question. In this research, scientists present a comprehensive global search for short-term precursory fault slip before large earthquakes. Utilizing global high-rate GPS time series data from 3,026 geodetic stations worldwide, scientists assessed fault displacement up to 2 hours before 90 different earthquakes of magnitude 7 and above. The statistical analysis of this data disclosed a subtle signal, aligning with a period of exponential acceleration of fault slips near the earthquake's hypocenter, starting roughly 2 hours before the rupture. According to the authors, these findings suggest that many large earthquakes initiate with a precursory phase of slip, or the observations may represent the concluding part of a longer and more challenging to measure the process of precursory slip. Despite presenting evidence of a precursory signal preceding large earthquakes, researchers caution that the current earthquake monitoring instruments lack the necessary coverage and precision to detect or monitor for a precursory slip at the scale of individual earthquakes. Although the results of research suggest that there may indeed be an hours-long precursory phase, it is not clear whether such slow slip accelerations are distinctly associated with large earthquakes or whether they could ever be measured for individual events with the accuracy needed to provide a useful warning.